Hey guys, welcome to lesson 4 of our unit 3, which is chapter 4 in your book. We're going to talk about matrices, and a lot of you probably haven't done a lot with matrices in the past, so a lot of this is going to be new. So I'm going to go ahead and draw what a matrix would look like, and then we're going to talk about it. Okay, so I just made up a random matrix. And so what a matrix is a way of organizing data or just numbers in any kind of way. And so that's it. So don't overthink like why we use a matrix. Matrices are described by the number of rows. So these are your rows right here. So I have 3 rows. And then the columns come next. So I have 1, 2, 3, 4. So it's really important that you know how it's named. So this is a 3 by 4 matrix. An augmented matrix, this is why we're doing it during this unit, because we've been talking about systems of equations. And an augmented matrix is another way to represent systems of equations. So if I have this system of equations and I want to put it into a matrix, I'm going to just grab the coefficients and put it in a matrix. So 3, 2, 5, 4, -7, 9. And this line right here tells, like, that kind of represents the equal sign. So notice that these are my x terms, 3x, 4x. These are my y terms, 2y, -7y, and then this is the 5 and the 9 are like my answers. Okay, so I want you to go both ways on this. I want you to convert this to a matrix and then convert this matrix to a system of equations. So go ahead and do that. Okay, so make sure like there is no z here, so that's where that filler comes into place, but there were 3 variables here. So we need to account for this. So this is like your x variables, your y variables, and your z variables. Okay, so the reason we do this is because we want to get it in reduced row echelon form. So what this means is I'm going to take a 3 by 4 matrix. So if I had a 3 by 4 matrix, I'm just making up numbers here. Okay, over here, this part is not made up. So this is the reduced part of it. Notice all these 1s that are diagonal and the 0s everywhere else. So this is what you want on the left-hand side. This is what we're looking for. So what this means, remember, this is your x, y, 0. So what this means is x is equal to 4. So x equals 4. Y, because you're in your y column, y equals 5. And z equals -6. So that's like, we know that we're done simplifying when it looks like this on the left-hand side and we have these numbers out here. So I want you to go ahead and state the solution as a coordinate point. So I didn't do this up here. So once you have this, these systems of equations, they meet at a coordinate point. So this would be my final answer. So go ahead and try it down here. Okay, so we have x equals 3 and y equals 6. So that was my answer. We have, notice 3, so you're just going to keep going. So x, y, z. So x equals 2, y equals 3, z equals -7. So this is my coordinate point. Okay, I want to talk about like some weird things that might show up. So in this case, it just looks like I don't have zeros here. So what this means is, like, let's go with the top row. So we have x, y, and z. So we have x plus 3y plus 5z equals 12. And we have y plus 2z equals 7. Now, this is a weird part. What it means down here is all my variables have canceled off, so 0 equals 4. So this is a case, just because of that guy, that it's going to be no solution. Okay, over here, the top is normal. So x plus y plus 5z equals 12. But down here, I have just a bunch of zeros. So what this means is that all my variables have canceled out. And this 0 equals 0 for both of those rules. So this is, or rows, sorry. So this is a case of infinitely many solutions. So I have the same line going on. So what I'm going to do is I'm going to grab this line up here. Remember, we have infinitely many solutions. We have to put the equation of the line in step filter notation. So I'm just going to grab that. So pretty easy. Oops. And this would be my entire answer there. Okay, so let's go ahead and get into solving an actual problem. So the first thing I want you to do is put this into a matrix. Okay, what Gauss-Jordan elimination says is that we're going to draw the diagonal because remember our goal is we want it like this on that left-hand side. So we want that 2 and that -4 to become 1s, but I'm going to start right here. So this guy on the bottom, this is my first step. I want to change him to a 0. So that is my goal. So I'm going to ask myself, think about systems of equations with elimination. So I'm going to erase all this so we can kind of make room. So when you have systems of equations and I need to get that to a 0, I already know that my top row is not going to be changed. It's going to look like that. So I think what I'm going to do is I'm going to multiply this by 5 and this by 2. I'll come over here and do that. So I have 10, 15, 30, -10, -8, 16. So my bottom row is going to be 0, 7, 46. And if you can simplify this at all, so let's pretend like this was a 7, 14. I would change that to like 1, 2. Like so, when you can simplify it, because both 7, 14, 7 goes into. So we're right here, and I still have those diagonals that I'm going to get to the very last. So my next thing that I'm going to focus on, remember I want that 1, 0, 0, 1. So then the next thing I'm going to focus on is that 0 right there. So I want this 3 to become a 0. So what I'm going to do is I'm going to ask myself, okay, what can I multiply this 7 by to get rid of this 3? So I'm just going to do, I'll do -3 and then come up here and do 7. So I have 14, 21, 42. I have 0, -21, -138. Okay, so on the top row, so my bottom row, remember I'm not touching my bottom row this time. So it looks like that. So on the top row, it's going to be 14, 0, and then 42 minus 138 is -96. And so what's jumping out at me right now is like these are both even numbers. So I might simplify it. I don't know. Let's see, 7, 0, -48, and then 0, 7, 46. I don't know how helpful that is, but whatever. So we still have this diagonal, and notice this doesn't have to be this way, but both of them are 7. So I'm just going to take the top row and divide it by 7, and take the bottom row and divide it by 7. And that is going to give me 1s here, and it'll look like this on the left-hand side, and I will have my final answer. So 48 divided by 7, that's not going to give me a nice answer. So I'm just going to keep it as a fraction. And it was negative, wasn't it? And then over here, I have 46 divided by 7, which also isn't a nice answer. So my final solution is going to be negative 48 over 7, 46 over 7. This is my x, so x equals negative 48 over 7. This is my y equals 46 over 7. So that is that Gauss-Jordan process. Okay, these other two are going to be nice numbers. So I want you to kind of take them as far as you can, and then I will go through them on my own and kind of explain it. Okay, so at this point, you should be pretty good at like getting it into the augmented matrix and knowing that you need to focus on this bottom left-hand element there. So I need to turn those to zeros. So think about systems of equations with eliminations and see how you can do that. Okay, so for this one, I ended up with 0, 10, 10. So I'm going to divide everything through by 10. And so I'm going to put not 0, 0, or 0, 10, 10. I'm going to put 0, 1, 1 because I'm going to simplify that. So this one is already starting off a lot easier. So my next number that I want to focus on is that negative 2. So I think, or the 2. So I think if we multiply this by negative 2. And I already know that I'm not going to change that bottom row. I just want that to a 0. So here, 4 through 6, and then 0, negative 2. Negative 2 is 4, 0, 4. So again, I know that I can multiply, divide everything through by 4 and get 1, 0, 1. So what's really nice about this is that I already have everything on the left-hand side. So x, 1, right, 1, 1, 1. So see if you can try this all on your own. Okay, so let's see. I multiplied this by negative 2, and I ended up with 7, negative 21. So I divided that by 7 and ended up with 1, negative 3. And I put that here. So notice I didn't change. I never changed that top row to begin with, only the bottom row. And so I multiplied this by negative 1 to get rid of that one. And I ended up with 204. So I divided that by 2 and simplified it and ended up with 102. So I had what I needed. So x equals 2 and y equals negative 3. And this is my final answer. That's it, guys.